Your text talks about what's called a skewness coefficient. This skewness coefficient has a formula 3 times x bar minus median all over the standard deviation. That means 3 times the difference between the mean and the median, all divided by the standard deviation. Now, what could be the meaning of that? Well, if we have a distribution like this, the mean x bar might lie here, the average of the distribution, because you might have a distribution that tails out here for a long ways, and the occurrences way out here tend to pull the distribution in this direction, whereas the median is really a little bit less than the mean. When you have a skewed distribution, that's going to happen. Anytime the distribution is heavier on one side than on the other, this thing's skewed to the left, the median will probably end up being to the left of the mean. Now this difference here is the x bar minus the median. If we take 3 times that for a reason that you don't need to understand at this point, again, you need a calculus-based statistics course before you'd even begin to need to worry about why the formula is what it is. This is just what it is for right now. Okay, so if you take 3 times that difference and divide it by the standard deviation, it gives you the skewness coefficient. Now, why should you be dividing by the standard deviation? It might be fairly apparent that if the distribution is heavily skewed to one side, then these two numbers, the mean and the median, will separate a little bit. And the more heavily skewed, the more they'll separate. But why in the world should you divide by the standard deviation? Well, simply because if the distribution is spread out very wide, then that would exaggerate the difference between x bar and the mean. If we took this distribution and stretched it out in this direction, we'd have a bigger separation here. But the distribution wouldn't be any more skewed, it would just be stretched out this way. It would still be skewed the same to the left, so that to correct for the fact that a wider distribution will exaggerate the separation, we divide by the standard deviation, which is the width of the distribution, in a sense. It's a measure of the width of the distribution. If we double the spread here, that's going to double the separation, but it would also double the standard deviation because it would double all the deviations. So that's the meaning of the skewness coefficient. And that might be of interest to you if you plan to pursue advanced degrees at some point, or to really delve in depth into the subject of statistics, which is very, very important for some careers and some fields of study.